Students, in previous class, I started with new chapter is Matter Around Us Pure, which is chapter number 2 of class 9. So I'll continue with the same chapter in today's class. In previous class, we have discussed about matter and how can we classify matter on the basis of its chemical composition. So in previous chapter, we categorized matter on the basis of physical properties. But in this chapter, we'll classify matter on the basis of their chemical properties. And how can we classify them? This I have discussed with you in previous class, like pure substances, impure substances, and we call them mixtures also. Then pure substances are of two types, elements and compounds. And impure substances, or we call them mixtures, are homogeneous and heterogeneous. This question also I have discussed with you in previous class, and what are the characteristics of elements, what type of elements exist in nature. This I have already discussed with you in previous class, and if you want to go through it, just look at that video in which I have explained these topics. And I hope you people have revised all the topics which I have covered in the previous session. So elements are of three types: metals, non-metals and metalloids. And what properties do they have? This we have already discussed, like metals are malleable, ductile, good conductor of heat and electricity, they are lustrous and sonorous. And examples of such kind of metals are copper, gold, iron, aluminium, zinc. And if we talk about non-metals, non-metals are non-malleable, non-ductile, they are bad conductors of heat and electricity except graphite, they are non-lustrous except diamond, and they are brittle, they can easily break, and they exist in solid, liquid and gaseous form. And metalloids are those which have properties of both metals and non-metals. So how these metals are different from non-metals, this I have discussed with you. And what are compounds? This also I explained, like compounds are those substances in which two or more elements combine together but in a definite ratio, in a fixed ratio, and we call them compounds. And what are its characteristics? Like whatever new substance or new product is obtained after mixing two or more metals, the property of that new substance is entirely different from that of the elements which were involved in its making. And compounds are homogeneous substance. They have fixed melting and boiling point. They can be separated by chemical processes. And question can come in exam on the basis of their properties, on the basis of their definition, or how can you differentiate elements and compounds. Now, today I'll start with mixtures. As I told you, mixture is also known as impure substance, because this when we are making mixture, there is no fixed ratio. Unlike compounds, they do not have any particular ratio. So whatever elements or compounds combine together to form a mixture, they are mixed in any ratio or in any proportion. The ratio is not fixed at all. So mixtures are those substances in which two or more elements or compounds combine together in a fixed ratio and proportion. And mixtures can be homogeneous or heterogeneous. So these two, homogeneous and heterogeneous mixtures, I'll just discuss later. First, let's come to another property. Whatever constituent substances are present in mixture, their properties remains. They'll not lose their property, unlike that of compounds. Whenever any element or compound mix together, they form a mixture, and whatever substance is formed, that has property of both the substances which were involved in its making. no new compound is formed. Only there is a mixing of elements and compounds. And these can be separated by physical processes also. And they do not have any fixed melting and boiling point. If we are talking about mixtures, mixtures are opposite to those of compounds. Like they are homogeneous and heterogeneous, or their constituent particles retain their properties. They do not lose their properties, whatever substances are present in those mixtures. And no new compound is formed. They can be separated by physical processes, and they do not have any fixed melting and boiling point. Apart from this, we are talking about types of mixtures. We have two types of mixtures, homogeneous and heterogeneous. First, let's take an example of homogeneous type of mixture. It's that kind of mixture in which when we mix two substances together, their boundaries cannot be separated. We cannot see their boundaries. It's not visible. For example, if you mix sugar into water, stir it properly, and you cannot see their boundaries. You cannot see, or you cannot differentiate the boundary of sugar and water. So it's a kind of a homogeneous mixture. Another example of homogeneous mixture is air. Now comes to heterogeneous mixture. Heterogeneous mixtures are those mixtures in which the boundaries of components which are present in them are clearly visible. For example, oil and water. When you mix oil and water together, so the boundaries are clearly visible. So these are the examples of homogeneous and heterogeneous mixtures. And what kind of mixtures, a type of mixture we have? If we have gas and gas, so I'll just write here whether it is a homogeneous mixture or heterogeneous mixture. We have different type of mixtures. Heterogeneous mixture. Okay, now first if I'll talk about gas in gas, it means if two gases or more than two gases combine together. So what type of mixture is this? It's a homogeneous mixture. An example is air. Now second is gas in liquid. Example is aerated drinks, like sodas and cold drinks which you are drinking. It's an example of homogeneous mixture. So these are the examples of homogeneous mixture. And if liquid in liquid, liquid in liquid, for example, alcohol and water. This is also an example of homogeneous mixture. And the next is liquid in solid. And the example of such kind of this is mercury in zinc amalgam. Okay, now in heterogeneous mixture, we are talking about liquid in liquid. So example of such kind is oil and water. Okay, now next is solid in liquid. So when we mix solid and liquid together, so what kind of mixture is this? Like NaCl, that is sodium chloride, salt, in water. And heterogeneous example is chalk in water. Chalk in water. When you mix chalk in a water, so you can easily see the boundary of chalk because it cannot dissolve in water. So you can easily see boundary of chalk and water. That's why it's an example of heterogeneous mixture. Then solid in solid. Yes, that solid in solid is example of homogeneous mixture is alloys, and heterogeneous is iron fillings with sand, Okay, so when we mix iron fillings with sand, so you can easily see where are the iron fillings and where is the sand. Okay, so these are the examples of different kind of mixtures, and these are types of mixtures. So these are types of mixtures which are mixed together, and whether they are homogeneous or heterogeneous, this I have mentioned here. So if you are talking about gas in gas, air is the example, clean air, or you can say clean air or air, it's a homogeneous mixture, which is a composition of carbon dioxide, oxygen, argon, neon, helium. So many gases are present. And if you're talking about gases in liquids, aerated drinks, like carbon dioxide in water. So that's an example of aerated drink. Cold drinks which you are drinking. Liquid in liquid, example of this is alcohol and water. When you mix alcohol and water together, they mix completely with each other. But if you're talking about oil and water, just now I told you, when we mix oil and water, we can easily see the layer, separate layer of oil over the water. Then liquid and solid, example is mercury and zinc amalgam, it can easily mix. Then solid in liquid, NaCl, which is sodium chloride, salt which we are consuming in water. When you mix salt in water, so it can easily dissolve. Or sugar, you can also take an example in this homogeneous mixture. And heterogeneous is chalk in water. It cannot dissolve. It makes a separate layer. And if you are talking about solid in solid, homogeneous is alloys. Example is brass. So bronze. These are alloys. Steel. So they are alloys which are a combination of two or more metals. So when they combine together, they form a homogeneous mixture because we cannot see the boundaries of each and every element. And if we are talking about heterogeneous mixture, an example of such kind of solid in solid is iron fillings with sand. So you can easily detect where are the iron fillings when you mix them with sand. So these are the type of the mixtures present. Now the question comes, how mixtures are different from compounds? As I told you, mixtures, they do not have any fixed melting and boiling point. See how mixtures are different from compound. If I'll see their differences, how they are different. If you're talking about mixture, they do not have fixed melting point and boiling point. On the contrary, compounds have fixed melting point and boiling point. And the second is constituent particles retain their properties. Whatever components are present in a mixture, their properties retain. Components properties are retained. They'll not lose their property. For example, when you mix salt or sugar in water, you can easily taste sugar and salt in a water. So their properties remains intact. While in compounds, it do not. Then third point of difference is the components which are present in mixture, they are present in any ratio. Their ratio is not fixed, but here they have fixed ratio. And apart from this, if we are talking about mixture and compounds, mixtures can be homogeneous or heterogeneous. Okay, and compounds are always homogeneous. Fine. So these are the differences between mixtures and compounds, and the examples of such kind of Or one more example, one more difference is there. In mixtures, there is no evolution or absorption of energy takes place. No absorption or evolution of energy, while in compounds it takes place. Okay, so these are the differences between mixture and compound, how they are different from each other. So I hope this is clear to everyone, how mixtures are different from compounds, how they are entirely different, what are their properties. And this question come in exam in 2 marks or 3 marks. So depend on the mark, just write down the points accordingly. Now define mixtures and list some characteristics of it, which I have already discussed with you. Mixtures are those substances that are made up of 2 or more elements or compounds which can mix together in any ratio or proportion. They do not have any fixed ratio. And the properties, they can be homogeneous or heterogeneous. The properties of constituents are retained. They will not lose their properties. No new compound is formed. Elements which are present in mixture, they can be separated by physical processes or physical methods, and they do not have any fixed melting and boiling point. So these are the properties which come under the this mixture. Now one more question is this. Water is a compound and not a mixture. Justify this statement giving 2 reasons. We are saying water is a compound and not a mixture. How can we say that? See, if you remember, I told you compound, when we make any compound, the constituents which are present in a compound, they are present in a fixed ratio. And if we look at the example of water, just look at its formula. It's H2O. And when hydrogen and oxygen combine together and they combine chemically to form water, so they boil at fixed temperature. It means they have fixed melting and boiling point. Okay, they have fixed temperature. So when you keep water in a freeze, so it becomes ice. When you take out, it becomes liquid. So it has fixed temperature. And the properties of the water are entirely different from those of hydrogen and oxygen. How can you say that? If you talk about hydrogen, it is a combustible substance, and oxygen is a supporter of combustion. And when we are talking about water, it extinguishes fire. So just see, the property of water is entirely different from those of hydrogen and oxygen. So that's why we call water a compound, not a mixture, because it follows all the characteristics of a compound. So that's why it falls under the category of a compound and not a mixture. So I hope this question is clear to everyone. Now, after this, physical and chemical changes. See, there are 2 types of main changes takes place: physical changes and chemical changes. How they are different from each other, let's see here. If we are talking about physical changes, so in physical change, no new substance is formed. And in chemical, a new substance is always formed. As I told you, H2 plus O, H2O, and it's a new substance, which is, the properties is entirely different. And properties of these constituent elements are entirely changed. So when any chemical change takes place, a new substance is formed. I'll take one more example, Na plus Cl, ACl, sodium and chlorine. Their properties are different. When it becomes salt, its property is entirely different from sodium and chlorine. So if we are talking about chemical changes, whatever new product is obtained, so that product has entirely different properties from those of its constituents. But if we are talking about physical change, no new substance is formed. For example, tearing of paper. When you tear a paper, only you are changing the size of that paper or shape of that paper, but there is no formation of new substance. Paper remains as it is. There is no new substance formed. So it's a physical change. And another example of physical change is melting of wax. When you melt a wax, so that wax converts from solid to liquid. Only state is changing from solid to liquid. Or melting of ice. Only there is a change in the state. Ice becomes liquid. So it's a physical change. Water remains as it is. If it is ice, then it is H2O. And when it becomes liquid, then also it becomes H2O. Okay. And when we convert it into gaseous form, again it remains H2O. So just see, no new substance is formed. Water remains as it is. Only there is a change in the state. So it's a physical change. But if we are talking about chemical change, melting of wax is a physical change. But burning of candle is a chemical change. How can we say that? Any idea? Look at the properties of physical and chemical changes. See, when we burn candle, it always produces heat and light, and some vapors, in the form of carbon, is released. It goes into in the atmosphere in the form of vapors. So it's a chemical change. New substance is formed when burning of candle takes place. Heat is evolved, light is it produces heat and light. Moreover, it produces carbon particles also. And the properties of carbon is entirely different from that of candle. So as you can see the difference, melting of wax. But if we are melting a wax changes its state only. It changes from solid to liquid. Only there is a change in the state. So that's an example of physical change, and this is a burning of candle is an example of chemical change. And when we are talking about physical changes, there is no involvement of loss or gain of heat. As just now I told you, and in chemical changes, there is loss or gain of heat takes place. And physical changes are reversible, but chemical changes are not reversible. When you melt wax, you can collect that liquid part, again solidified it. It became solid wax. When you tear paper, you can recycle that paper and it again becomes a paper. So these are reversible changes. But if we are talking about chemical changes like growth of human beings, that's a chemical change. Digestion of food is a chemical change. These are irreversible changes. So chemical changes cannot be reversed. Like rusting of iron is a chemical change. So this is how physical changes are different from chemical changes. I hope till here it's clear to you. Now, what type of question can come in exam? How is a chemical change different from a physical change? So in this type of question, you need to write difference between physical and chemical changes. Just see how much marks it carries. If it's of 1 mark, so simply you can write, in a chemical change, a new substance is formed as a result of chemical reaction, and no new substance is formed in a physical change. Or you can write any other property. It's up to you only. But if it comes in 2 or 3 marks, you need to write all these points which I have explained. Or might be question can come in this form: by melting of wax is a physical change and burning of candle is a chemical change. So in that question, you need to explain that when melting of wax takes place, there is only change in the state of matter or change in state of wax. While when burning of candle takes place, there is an evolution of heat and light and carbon is produced, which is a new substance. So that's why burning of candle is a chemical change. or they can ask any other question by giving any other example. So don't worry about it, just write their properties of physical and chemical changes and then write your answer. And generally this type of question can come in 2 marks. So it's basically a reasoning question, so you have to give reason. And for reasoning, you need to write the properties of physical and chemical changes. Now, next is solution. We are saying when 2 or more elements combine together or compounds combine together, they form a mixture. So, solution. Now the question arises, what is solution? Solution is a homogeneous mixture of 2 or more substances. Now, when 2 or more substances combine together, they form a solution. And if we are talking about solution, it is a homogeneous mixture, and we call it a binary solution also. Binary solution. Binary solution means it has 2 phases. It means 2 things are present, 2 components are present in a solution, and these 2 components are solute and solvent. So why solution is known as binary solution? Due to the presence of 2 components in it, that is solute and solvent. So, and what are the characteristics of a solution? So as I told you, solution is a homogeneous mixture, and it is composed of 2 components, solute and solvent. The size of the particles of solution is very small. We cannot see it with the naked eye or very simple microscope. So the size of the particles of a solution are very, very small. They will not show Tyndall effect. That I'll explain later what is Tyndall effect. Apart from this, so these solutes of a solution cannot be separated by filtration or decantation methods. Then apart from this, solutions are stable. Solutions are stable. So what are the properties of solution? They are homogeneous. First is they are homogeneous. They are binary. Then third is particle size is very small. They do not show any Tyndall effect. Then they cannot be separated. Just a second. They cannot be separated by filtration. Cannot be separated by filtration or decantation. Filtration and decantation. So these are the properties of the solution. Now, what are the conditions to be a solution? What conditions do they have? The components of mixture should not react with each other. That is the first condition. And when we mix them together, it becomes a homogeneous. So solution, if we want to make any solution, so there are 2 conditions basically. It should be homogeneous, and the second one is the components which are present in a solution, they should not react with each other. And for example, here is a beaker in which water is present. There is a water. Okay. Now if I add salt into it, so these are the 2 components which are present in a solution, salt and water. So this salt, the substance which is dissolved, is known as solute, whose amount is minimum, and the substance whose amount is maximum is known as solvent. So in this case, this water is a solvent. And when this salt and water mix together, then they form solution. So these are the two phases or the two components of a solution. So solute are those substances which can be dissolved in a solvent, and their percentage or the mass is less than that of the solvent. If you are talking about solvent, the liquid part is known as solvent and its percentage or mass is more than that of the solute. So these two, when combined together, they form a solution. So I hope it's clear to you. Now, what type of solutions do we have? There are different type of solutions. Let's look at the examples of such kind. First is aqueous solution, non-aqueous solution, true solution, saturated solution, and unsaturated solution, or solution can be dilute or concentrated. So we have different types of solution. First, I'll take aqueous solution. Aqueous solution is that type of solution in which solvent is a water. Just now I told you, when we mix two things together, two components are present, it's a liquid part, and if solvent is water, so this type of solution is an aqueous solution. An example of such kind of aqueous solution is salt and water, sugar and water. And second is non-aqueous solution. Non-aqueous solution is that type of solution in which solvent is not a water. Instead of water, it can be anything. It can be alcohol, it can be iodine. So that kind of solution is known as non-aqueous solution. Now, example of such kind of this, like sulfur and carbon disulfide, or you can take an example, alcohol. When mixed with, see here, this alcohol, it again, alcohol acts like a solvent here. So when we mix iodine in alcohol, we call it tincture of iodine. Tincture of iodine. Okay, so in this case, as you can see, non-aqueous solution, here alcohol acts like a solvent. So these type of solutions in which water does not behave like a solvent, we call them non-aqueous solutions. And here, when alcohol mixed with iodine, we call it tincture of iodine. Now come to true solution. Just now I have explained you, in true solution, the solute particles are very small. We cannot see it with the naked eye or with a simple microscope. And the particles of solute are extremely small, so they can easily mix together. Example of such kind of true solution is sugar and water. Then we have saturated solution. Saturated solution is that type of solution in which we cannot add more solute after a certain period of time at a given temperature. Suppose, I'll take an example of water and then I'll add salt into. Okay, here salt is a solute and water is a solvent. Fine. It's a solute. It is solute and it is solvent. So when we mix them together, when we keep on mixing salt into water, a stage will come when we cannot add more salt in water. It will stop dissolving. So then at that stage, that solution is known as a saturated solution. So saturated solution is that solution in which no more solute can be added at a given temperature. And if we are talking about unsaturated solution, these are that type of solution in which we can add more solute. So these are unsaturated solutions. And we can easily convert, or we can easily change saturated solution into unsaturated solution. And there are two conditions for this. If we increase temperature, if we increase the temperature, we can add more salt. We can add more solute into it because it gains heat, it gains energy and start creating more space. As a result, we can add more and more solute into it. So if we increase the temperature, saturated solution can be easily converted into unsaturated solution. And second is by adding more solvent. If we add more water into it, so the percentage of water, the percentage of solvent increases, and now we can add more solute into it. So there are two conditions. Under these two conditions, we can easily convert saturated solution into unsaturated solution. And it's a 1 mark question. Can we convert saturated solution into unsaturated one? And the answer is yes. And if it comes in 2 marks, so examiner can ask in this way, how can we convert or how can we change a saturated solution into unsaturated solution? Or what are the conditions involved in it? So in that answer, you need to write by increasing temperature or by adding more solvent, we can easily convert saturated solution into unsaturated one. So these are the types of solutions, and the next is dilute or concentrated. These type of solution depend on the amount of solute dissolved in solvent. Dilute or concentrated. If we are talking about dilute, in dilute, the percentage of solvent is more. In dilute, the percentage of solvent is more, while the percentage of solute is less. Okay, so this kind of solution is known as dilute solution. And if we are talking about concentrated solution, it's just opposite to that of the dilute one. Here, in concentrated solution, the percentage of solute is more and percentage of solvent is less. Sometimes we write concentrated H2SO4, dilute H2SO4. So what does it mean? We write like this: dilute or concentrated HCl. This is hydrochloric acid. So it means in this type, acid is 90%. Acid is merely 10% and water is 90%. And in concentrated, it's just opposite. Here, acid is 90% and water is merely 10%. So these are the different type of solutions which we have. I've just discussed all type of solutions with you, and if you have any doubt, you can ask. I hope till here it is clear. So these are the type of solutions which I have discussed with you, and these are the characteristics of a solution. Like they are homogeneous, binary, the particle size is very small, they show Tyndall effect, they cannot be separated by filtration, decantation. So these are the properties of a solution. And today I have discussed about I've already discussed about physical and chemical changes, how physical changes are different from chemical. So I hope till here it's clear. Now, how can we find out the concentration of solution? How can we find out how much amount of solute is present, how much amount of solution is present? So there is a formula: amount of solute upon amount of solution, or amount of solute upon amount of solvent into 100. Then mass by mass percentage, if you need to find out the mass percentage of solute and solution, then in that case we need to use this formula: mass of solute upon mass of solution. Mass by volume percentage of a solution is mass of solute upon volume of solution. Then these are the formulas which we use for finding the concentration of solution: mass by mass percentage or mass by volume percentage of a solution. Okay. So now I'll just wind up my today's class with these topics. And if you have any query, you can ask. I'm waiting for your response. And if you have any doubt from the previous topic also, you can ask, so that I'll take your doubts. Show you slides, whatever we have discussed today. Today's class, we have covered mixtures and its properties, how mixtures are different from compounds, and how physical and chemical changes are different from each other. What is solution, what type of solutions we have, and what are their properties, and what are the components present in a solution. This I have already discussed with you. Then types of solutions: aqueous solution, non-aqueous, true solution, saturated, unsaturated, dilute or concentrated. And how can we find out the concentration of a solution? So numericals based on these formulas I'll discuss in next class, so that it will be more clear to you how can we find out the concentration of solution, and how can we find the mass percentage of a solution or mass by volume percentage of solution. So these we can, and how can we use these formulas? So this I'll explain in next class. So before that, you need to learn all these formulas so that you can easily solve numericals based on these formulas. Okay, if you have any doubt, you can ask. So thank you.